Hello, we are FTC Team 14503, the Robo Sapiens, and this is our Control Award video. This season, our autonomous program has improved significantly with the use of odometry, Roadrunner, and PID. The video you see now is a sample autonomous game with 4 rings in the starting stack, which is our highest scoring possibility with up to 107 points. As you can see, the first thing we do is detect the stack height with OpenCV. Then we deposit the first preloaded wobble goal, align to the high goal and shoot 3 preloaded rings, and collect 2 to 3 of the rings from the starting stack. We also collect the second wobble goal, and with it in hand, we shoot those rings that we collected, deposit the goal, and finally park on the line. Again, this is our high scoring possibility, but we can also get up to 71 points with the 0 ring randomization and up to 83 points with the 1 ring randomization. The main reason for our autonomous program accuracy is odometry. We have 2 perpendicular spring-loaded dead Omni wheels on a robot that spin freely with no motor, only an encoder that tracks the number of revolutions. Using advanced trigonometry with the motion in each direction from the dead wheels, along with a gyroscope from the RevHub IMU, we are able to determine the robot's pose on the field in terms of x, y, and theta, or heading, extremely precisely without risk of slip and blocking. This calculation can later be used by Roadrunner. Another successful control element for us this year was the use of OpenCV. Our code draws a green square on a predetermined portion of the camera's view over the starting stack of rings, and with it determines a count of orange pixels. It then compares this with a threshold value for each possibility to determine the number of rings in the starting stack. You can see an example of our code and the changing values as the number of rings in the stack changes in this.
Roadrunner is a path planning trajectory system that uses splines to generate accurate and efficient trajectories to move to a certain coordinate. With odometry, you can see on the computer screen that the robot is accurately tracking its position relative to the trajectory and following it with precision. We use a custom-tuned PID-F controller to accurately maintain our shooter velocity so that our shots always make the high goal. You can see on the top right how our velocity quickly jumps back up to the desired velocity after shooting a ring. With the push of a button, our go-to-position method automatically drives to our predetermined coordinate to minimize our driver error during tailgate. To improve our cycle times, we have created a button that automatically shoots all 3 rings, maximizing our shooter efficiency. Our translational PID-F controller measures error over time with odometry. It will then efficiently and accurately correct its x, y, and theta coordinates. This will be useful when there are other robots on the field which we may collide with.
Thank you for watching our Control Award video. Feel free to ask us any questions about the topics in this video during our interview time.